So in this session, we discuss about propositions, or what we call statements in logic. So a statement or a proposition is a declarative sentence which is either true or false, but not both. So the key thing is that is what can be classified as true, or if you can't classify it as true, to classify as false, but not possibility of having false and true at the same time, or not having a clear cut on how to classify as either true or false. Now, examples. Examples of propositions. We can say, one, Earth is the closest planet to the sun. Number two, man is mortal. Number three, we can say 3 plus 5 is 100. Number four, we can say sun rises in the east. Number five, we can say 6 is greater than 0. Number 6, we can say 6 or 16 is an odd number. Another example can say Nairobi, the capital city of Rwanda. Another example we can say that 9 is less than 46. Another example we can say tomorrow is my birthday. Number 10, we can say sugar causes tooth decay. Number 11, another example for proposition or statement, we can say a sign, Euler was right-handed. Number 12. White rhinos will be extinct in 6036, and other more examples. So of these examples, you know that there are statements which you can always know their truth values. Like when you say Earth is the closest planet to the sun, we know that this is false. From science, we know that the closest planet to the sun is Mercury. And then man is mortal. That's also can also be classified. 3 plus 5 is obviously not equals to 100. So this actually also a false statement. And then sun rises in the east can also be classified. And then 6 is greater than 0. This is actually a true statement. So the truth value of this one is true. And 16 is an odd number. We know this one is false. And Nairobi is the capital city of Rwanda. This is not true. So this is false. 39 is less than 46. It's actually a true statement. And then, now when we say tomorrow is my birthday, this one is a proposition because the person saying this statement can either be we know that the birthday of one person, any given normal person, is just 1 day per year. So when someone says tomorrow is my birthday, depending on the person who's saying that statement, it will just have one answer, either being true or false. So for someone who indeed has a birthday tomorrow, the truth value of that will be true, but any other person, the truth value will be false. So you realize that sometimes a proposition may be true and sometimes may be false, depending on where and when it was stated and by whom. So for instance, when you say that the person who says that tomorrow is my birthday will be true if the person saying actually has a birthday tomorrow, but for any other person who doesn't have a birthday tomorrow, then it will be false. But it's not possible for one person to say that today is tomorrow is my birthday and also not my birthday. It's not possible. Just have one, and it says that it's either it's your birthday or it's not your birthday. And then when you say sugar causes tooth decay, that is a true statement from science, that indeed when you take a lot of sugary substances, especially for kids, then they can actually spoil their teeth. So that is true from science point of view. But then when you say statements such as Euler was right-handed, we may not be able to know, but then the assumption is taken that any normal human being is either right-handed or left-handed. So for those who saw Euler, it will be true when if he was right-handed, or if he was left-handed, then this will have a truth value of false. But then the assumption is taken for such kind of sentences is that a person can just either be a right-handed or a left-handed, but not both. So we remove those ambiguities or abnormalities. And then when we say white rhinos will be extinct in the year 6036, that's still a statement because being extinct simply means that no white rhino will be existing at that time. So it can either it will be true or false, but it can't have two answers. Either the rhinos will not be there or they will be there. So that's why we classify that one as a statement. Now, let's give examples of non-statements. And before we give examples of non-statements, it should be noted that, so before we give the examples of non-statements, so remark or NB, exclamations, questions, and demands are not statements. Since they cannot be classified, or declared as true or false. So this simply means that now, immediately you see any sentence with this exclamation mark or this question mark, then it disqualifies that sentence being a statement or a proposition. Also, rumors which cannot be justified, opinions which cannot be justified, then also are not classified as propositions. So one, for example, we can say, come here. This is like a demand. So come here is not a statement. Number two, when you say X is greater than 3, this one is not a statement because it could be true. So maybe just a reason for this. Not a statement because it could be true. Or false, depending on the X value chosen. But then remember, when we add a condition to that X, what we expect it to be, then it will actually have a fixed answer, then it can be classified as a statement. 3, what time is it? So this is a question. So it can be classified as a proposition. And number 4, keep off the grass. Keep off the grass. So this cannot actually be classified as true or false. So that's like a demand. So which can actually not be classified or declared as true, either true or false. Another example, this So you can say this like an opinion which cannot be substantiated, or maybe depending on whoever's the person saying such, the same thing may be true or false at the same can't really be classified as true or false at the same time. Number 6. Did you finish your homework? And number 7, you can say she lives in Nairobi. Now, she lives in Nairobi is not a statement because she can be anyone. So maybe just put in brackets why this one is not a statement. So this may be true or false. But then now, to make things clearer, get this. When you say x is greater than 3 for an integer, for any integer, say for any odd integer greater than 4, then this becomes a statement because now there's more information given to what x should be fixed. So all these things will actually have one interpretation. All the values you put here for x, this according to this condition, will actually give the same result. For those numbers will be greater than 3. That'll be true. But then when you just say x greater than 3 and you keep quiet, then this becomes non-statement. So this non-statement, while this one is a statement, because there's extra information given on x. Now, when you say Eric lives in Nairobi, now this becomes a statement because we are now specific to the person we are referring to. So assumption taken here that now this Eric is someone already we know. And so he's the one that we are referring to be living in Nairobi. But when now we replace this one by he lives in Nairobi, then this becomes a non-statement because he is two gender. Non-statement. So that's really what we understand by statements and non-statements. And then remember, statements are denoted by letters. So for instance, letters, we can use lowercase letters A, B, C, or we can use uppercase letters, or you can even use subscripts, whichever way you like to do it. So you can say, for example, A, and then you put colons. The sun rises in the east. So this is what we call the proposition A. Or we can say another proposition, we call it B. Tomorrow is my birthday. And then we can say another proposition, we are calling it C. 3 plus 4 is 6, etc. And then propositions are expressed or represented in a table we call a truth table. So a table that summarizes truth values of a proposition or statement is called truth table. And so the truth value of a proposition is the truthness or the falsity of a proposition. So it can either be true or false. True is represented by capital T or sometimes a digit 1, and false is represented by capital F or digit 0 in some cases. So that is what we have to know about propositions. And so maybe just if they should be very clear that, like when I write root 17, it's an integer. These are proposition because we know that root 17 will not be an integer. So it's a proposition whose truth value is false. And then when you say x plus 1 is an even integer, then this is not a statement because it may be true or false depending on the numerical value assigned to x. So we can say this is not a proposition. Not a proposition. Because could be true or false depending on the value assigned. Like if I put here 1, it's true that 1 plus 1 is 2, it's an even integer. But if I put here 2, then I'll get 3. So it's not true. But if we had said x plus 1 is an even integer, for all values of x that are odd. Or for all integers x that are odd, then it will be 2. Or even if we say for all integers that are even, then it makes sense because we'll just have one value. But now, when you leave it open that way, is giving a possibility of being true or false depending on the numerical value assigned to us. So thank you.